Just a student, now I have defined you next example. Yes, example 2. Yes, example 2 for the Fourier series. Here find, yes, find Fourier series corresponding to the function f of x defined in -2, 2 in this range as follows. Here the function is defined as f of x, which is defined as 2 if -2 is less than equal to x is less than equal to 0, and for x if 0 is less than x is less than 2. Yes, for this interval we have to find out the value is this one. Okay, yes. Now for this one we suppose here you use the property as minus L to L, because here is -2 to 2, so you use the problem for the -2 to 2, that is you use the for this is minus L to L. Yes, for this one you use. Okay, so for this question we use this. Yes, the solution of this example is defined as, yes, earlier I have defined you the problem is as, yes, this one for minus L to L we have defined you. Next result I have defined you minus that is the range, in the range minus L to L, so we defined using this property, and now we use this one. Okay, here, yes, here the interval is -2 to 2. Yes, yes, you say that here the interval is -2, yes, -2 to 2. So L is equal to 2. Okay. Now, according to this, now earlier we have proved earlier the result for the Fourier series and also for the minus L to L. Here, if f of x is equal to a0, yes, 1 by 2 a0 plus sigma n is equal to 1 to infinity, yes, a n cos n pi x by L plus b n sin n pi x by L, yes, this one. So here you find out a0, an and bn similarly. So here in this, here you know that, yes, my a0, yes, here a0 is this one you have proved earlier, 1 by L minus L to L, yes, f of x dx. So this is equal to, here is 1 by 2, L is 2, so 1 by 2, yes, -2 to 2, so you can write it -2 to 0, because here is -2 to 0 and then 0 to 2. Okay, so here is from -2 to 0, and the function value is, here is 2, yes, dx plus 0 to 2, and the function value is, here is given as x, yes, so you can substitute here is x dx. Okay, so this become value is 2dx. So solving this is x, so solving this you get the value is, yes, 1 by 2 of 4 plus 2, that is you get the value is 3. That is you get A0 is 3, or you say that A0 you get this one is 3. Okay. Now we find out, similarly you have to find out AN. Yes, AN, and AN is 1 by L minus L to L. Okay, f of x cos n pi x by L dx. Yes, so this can be written as you break up in this same form, minus 2 to 0 and then 0 to this one. Yes, so this one is L is 1 by 2, and now this can be written as minus 2 to 0, and f of x is, yes, f of x is 2 cos, yes, n pi x by 2 dx. Yes, plus 0 to 2 x cos n pi x by 2 dx. Okay, now here is again, yes, minus 2 to 2, this one. So solving this, you can also, we have clear it all the terms for the integration. Okay, here is 2 is here, integrating this one. Yes, integrating minus 2 to 2 dx. This become 4 by 4, integrating this one, so this become 2 by pi n pi, yes, sine n pi x by 2. Okay, and the limits from minus 2 to 0, and here is again plus, here is 2 terms, so integrating the same form, that is x 2 by n pi, yes, x 2 by n pi sine n pi x by 2, and plus integrating, if this one, then you get plus 4 by n square pi square cos n pi x by 2, and the limits from 0 to 2. Yes, you have cleared it, integrating this and integrating this, 2 by n pi x, and here is sine n pi x by 2 plus 4 by n square pi square cos n pi x by 2. Okay, that's clear? Okay. If you take the limit, then you get an is, if you take the limit, then you get, again you get this, and you get 1 by 2, yes, and here you get, yes, this one you get 4 by n square pi square cos n pi minus 4 by n square pi square. Yes, if you solving this, then you get 2 by, yes, this one, n square pi square, and here is again you generalize this value, so this is minus 1 to the power n. If you take in here a common, so this one is minus 1. Yes, this is the value of an. Yes, I think you have the value is clear now. So according to this one, you can define this for odd or even, or yes, therefore the value is minus 4 by, yes, n square pi square if when n is odd. Okay, if you odd, then the power is like that, minus 1 like that, minus means 1, 3, 4, then this is minus 2 and multiplying this and this. If this is, yes, and similarly if this you get the value is 0 if we substitute the n is when yes n is even. Yes, 2, 4, then you get always positive. If positive, then 1 minus 1, that is this becomes 0, so everything is 0. This is the value of an. I think you have cleared it. Okay, now similarly on the same way we have to obtain the value of bn. Now bn, okay. Now we obtain bn. For bn you also to apply, you know that from the definition you that which is equal to 1 by L minus L to L, yes, f of x sine n pi x by L dx, and substituting on the same way in the 2 term, that is 1 by 2 minus 2 to 0, yes, 2 sine n pi x by 2 dx, yes, plus, yes, 0 to 2 x sine n pi x by 2 dx. Is clear? Okay. Now solving again similarly as you for the an, similarly you can solve in this one. Okay, integrating this one, and now if you solve it, then you get this is again is equal to 1 by 2, and here you get 2 times minus 2 by n pi, yes, cos n pi x by 2, the limit from minus 2 to 0, plus again here is next term is you get minus x, yes, and here is again minus 2 by, yes, or you can say that minus 2 by n pi, this integrating, okay, here if you write this integral, yes, n pi, this one, and minus 2 by cos n pi x divided by, yes, 2, yes, and now next term is plus 1, the integration of this is 1, differentiation of x is 1, so 1, and 4 by n square pi square sine n pi x by 2, and the limits from 0 to 2. Okay, yes, the limit from 0 to 2. So solving this you get, this is again is equal to, you get 1 by 2, and here is minus 4 by n pi plus 4 by n pi cos n pi, yes, and similarly here is, if you 1 by 2 is here is again bracket, then 1 by 2, and this is again is minus 4 by n pi cos n pi plus 4 by n square pi square sine n pi, and limit from 0 to 2, then you get this one. Okay, now solving this you get the value is, this is equal to minus of 2 by n pi, yes, you get the value is minus 2 by n pi, yes, this is bn. Yes, solving it minus 4 pi, and this one is again is plus, so this cancel out now, this one, yes, so this one become, and here is sine of n pi, so you get, yes, you get the value, and substituting this, now you get this one is equal to, yes, this 1 by 2, yes, checking all the values, yes, this one, plus 1 by 2 of minus 4 by n pi cos n pi, and also the value of this is, okay, yes, Therefore, the required Fourier series is, yes, therefore the required Fourier series is fx, that is substituting all the values of in this series a0, an and bn. Yes, you can say that, or in equation number 1. F of x is equal to a0 by 2 and a1, a2 expanding this series. Yes, if you expand the some terms, then you can say that a0 by 2 plus a1 cos n pi x n pi by l, yes, and plus a2 cos 2 pi by, yeah, n is, if you substitute n is 1, then here is also not n, is, this is x pi. If you 2, then this is 2, yes, x pi by l plus a3 cos 3 x pi by l plus up to so on. Similarly, bn the terms, b1 sin, yes, x pi by l plus b2 sin 2x pi by l, yes, plus a b3 sin 3x pi by l, yes, plus 2, so on. Now it is easy that you substituting all the values of a0, a1, a2, now so on. You can substituting these values because you have to find out an is again. So you can an, a0, all these values you know. So substituting these values you get, this is, here is a0. What is a0? a0 is 3. Yes, a0 is 3 here. So this one is equal to minus 3 by 2. So sorry, not minus, because it's a plus 3 by 2 minus 4 by pi square. 4 by pi square, 1 by 1 square cos pi x by 2 plus 1 by 3 square cos 3 pi x by 2 plus up to so on. This one become, if you take the this integral is okay, this one, yes, and also this one, the series expanding this one, and also similarly for the b1, that is minus of 2 by pi, and here is 1 by 1 sin pi x by 2, yes, plus 1 by 2, yes, sin 2x, yes, 2x pi by 2 plus, yes, now so on, 1 by 2 of this is 1 by 1, 1 by 2 plus 1 by 3 sin 3x pi by 2, yes, up to so on. Yes, therefore the series f of x is this one. Okay, clear it? F of x is equal to 3 by 2 because a0 is 3, so 3 by 2 minus a1 here is this one, minus 4 by pi square, then minus 4 by pi square, and all the values of cos this term, and similarly for this. Okay students, you have cleared it. Okay, now next video I have defined you some other questions of Fourier series. Okay students, thank you.